Okay, people, here are the notes for section 3.1. In this section, we're going to start looking at ratios, and we're going to look at these for really the whole chapter. A ratio is just a comparison of two quantities. So, for example, if we have 5 dogs and 3 cats, what's the ratio of dogs to cats? Well, we could write it this way, 5 to 3, using the word 2. We could use these two dots or this colon here, 5 to 3 is another way to write it. Or the other really common way to write a ratio is to use a fraction. So 5 over 3. 5 dogs to 3 cats. I like fractions the best personally, but all these are great. And we can treat all of these like a fraction. On your assignment, you're going to have to simplify them or reduce them a little bit, and I'll show you a few examples of that later. So you could use the word 2, the two dots, a colon, or a fraction. And that's how they'll look in the book when they are writing out ratios. Okay, a special kind of ratio is a rate, similar word there, rate. So a rate is a ratio of two quantities, with two different units. And you see these all the time. So for example, when we talk about driving and speed, if you drove 100 miles in 2 hours, then the rate would be 100 miles in 2 hours. So see, the units are different here. Here we have miles, here we have hours. You see rates in stores all the time when you're looking at the price of things. If you look on the labels on the shelves, you'll see often unit rates, which we'll talk about in a minute, but you'll see rates everywhere. So say apples cost $9 for 3 pounds, well that's $9 to 3 pounds. Again, I like to write them as a fraction, especially in this situation. It looks kind of funny to use a colon or the word to. Oftentimes when we're talking about something like this, we use the word per. So 100 miles per 2 hours, or as you'll see in a minute, that would be 50 miles per 1 hour. And that's another way to talk about it. Okay? So again, a rate, we have two different units. Here we have miles on top, hours on the bottom. Here we have dollars on top and pounds on the bottom. Okay, and as I mentioned a second ago, we have something called a unit rate. And a unit rate is just a ratio or a rate where the denominator is 1. And that's really a much easier way to think about things, especially like a speed. If you told someone you drove 100 miles in 2 hours, well, they really want to know how fast you were going, and to do that, you would use a unit rate, which is 50 miles in 1 hour, or as I said before, 50 miles per hour. Okay, so there's a unit rate. So what we did, we just simplified this. We just reduced it to get a denominator of 1, and I didn't write the 1 down there. So it's 50 miles in 1 hour. Let's say you spent $9 for 3 pounds of apples. Well, people want to know, well, how much was it per pound? And I think you can see $9 for 3 pounds is $3 per pound. So that's a unit rate. It's $3 for 1 pound. Again, a denominator of 1, or the second quantity is a 1, so it's $3 for 1 pound. Okay, so you'll have to turn some rates into unit rates on your assignment too. And these are the rates that you see most of the time. This is what people want to know. They want to know how much is it for one thing. How many miles in 1 hour, how many dollars in 1 pound, things like that. So just a few examples of what you're going to see on your assignment. So let's say you worked for 10 hours and you got $8 an hour. Well, how much money did you get? 10 hours, $8 an hour. Well, as I think most of you will recognize here, that means you got $80. The idea with this is something that you'll learn and you'll use later on, especially when you take chemistry in high school. And that is, we can cancel units out. Look, I can just cancel those H's out. 10 hours times $8 an hour is $80. The hours cancel out. That's something called unit analysis, which is like I said, a really important thing to learn when you take science in high school. Okay, you'll have to write some ratios in simplest form. It's just reducing, even if it looks funny with the word 2 in it, or if it has a colon. So we just reduce these like we normally would, right? 55 and 35, let's see, 5 goes into both of those. Divide them both by 5. And we get 11 over 7, and that is completely reduced, so we're done. If it helps to write it as a fraction, you're welcome to. I'm going to leave it like this because this is how it showed up in the problem with the word 2 in it. But what can you divide into both 12 and 8? What's the biggest number that divides into both of those? Well, it's 4. So I'm going to divide each of these by 4. Okay, divide by 4, divide by 4, and 12 divided by 4 is 3. So this ratio in its simplest form is 3 to 2, because I divided each of those by 4 to reduce it. Okay, 60 to 9 using this colon symbol here. Now what's the biggest number that goes into both of those? Well, I think it's just 3. So this one is going to be equal to, let me write it down here so it's not quite so messy. If I divide each of these by 3, 60 divided by 3 is 20. And 9 divided by 3 is 3. So again, what I did here was I divide both quantities there by 3 to get my simplified ratio, which was 20 to 3. And again, I'm going to write it the same way as it came in the problem with the colon. Okay? So hopefully that's okay. If it's simplest form, you know how to do that. You're just reducing it. If you don't like the word 2 and you want to write it like a fraction because it's easier for you to reduce it that way, that's totally fine. Just notice that the answer in the book may have the word 2 in it, or it may have a colon if you do end up changing it to a fraction. Either way is completely fine with me on a test, however. Okay, and I think there's one more thing, and that has to do with the unit rates. Okay, so 320 miles for 10 gallons. So I will write this one like a fraction. So this is 320 miles for 10 gallons. And we want the bottom, we want this denominator to be 1, so just a gallon. Again, I'm not going to write the 1 there. So if I divide by 10, so 320, let me write that over here on the side somewhere. So 320 divided by 10 equals 32. Because 10 divided by 10 is 1, so 320 divided by 10 is 32. So that's 32 miles for 1 gallon, or as we often will say when we're talking about gas mileage, 32 miles per gallon. And the way we often abbreviate that is like this, 32, oops, sorry, that's a 2. I'm just going to write that all over again. 32 miles per gallon. MPG is how that's often written. Miles per gallon. That's a unit rate. So you do see unit rates really everywhere. They're all over the place. Okay, so let's say we spent $4.40 for 8 pounds of candy. How much was it for 1 pound of candy? So what I'm going to do here is I'm just going to divide. Okay, so 440 divided by 8. Okay, whole number here, we're good. We don't have to move the decimal anywhere. I'm just going to swing it right up on top here. Does 8 divide into 4? Nope, it does not, so there's a 0. Okay, now how many 8s divide into 44? Well, that's 5. 5 times 8 is 40. Let me subtract 40 here. I got a 4 and another 0. And 8 goes into 40 again 5 times, so minus 40, and we're done. So again, I want a 1 on the bottom. I want 1 pound. So 8 divided by 8 is 1. So I'm going to do $4.40 divided by 8 to get 55 cents. So the unit rate here is, I'm going to write it using dollars, 55 cents per pound. Again, I don't write the 1 on the bottom. Okay, so again, unit rate is a 1 in the denominator for whatever that quantity is. Here it's 1 pound, here it was 1 gallon. On your assignment it will be mostly the same thing. It might be hours, or it could be minutes, or whatever it is in the problem, but it's just going to be like this. So you just have to do some dividing or some reducing. Okay, well, I hope that is enough to get you through section 3.1. If you have any questions whatsoever, please let me know. Thank you.